it's Chris. Hi guys. Did how many people got to point your cursor up here just by a show of hands? Did anybody? These two guys, a couple back there. Did anybody want to that didn't get to? I kind of want to show you guys again how this works and let you try it. This is really beautiful. I'm going to clear it out, but just know that I think it's beautiful. So here's how it works. If you guys want to follow along with me, I've got my phone up here. You guys can see yourselves. I'm sure you love that. If you have a camera, you can point your camera at the QR code, and you get a little prompt, and you can tap the prompt, or you can type that little short URL, and you get something that looks like this on your screen. And once you get that, I see some people following along. That's good. Maybe you're welcome to do this if you want. It's not going to hurt anything, break anything, or embarrass you. Oh, somebody's already doing it. So when you get that, you get like flashing numbers on the screen. Point your phone at the screen. I'm going to point at my laptop and point at the screen and tap once, and that calibrates your pointer and gives you a little colored cursor to move around and wiggle around if you want. And if you want to, you can hold down while you're moving your cursor. I'm that blue guy doing the spirals up top. You can draw whatever you want. Go ahead. See some crazies down here at the bottom. Secret artwork happening down there. That's cool, right? Like, you snap a QR code. Yeah. Oh, that's what that says. I'm sure that's not your normal handwriting. Anyway, I promise there will be more to the presentation than this. But that's... should just leave it up there. Go ahead. You get a couple more seconds. That's pretty good, guys. I think that's good. So this is really similar to a thing that we did at Paradowski, where I work. About a year ago, I got it recording. Yeah. About a year ago, we did this thing that's on screen right now. I don't know, do any of you guys work remotely? Anybody work remote? Yeah, a couple of folks. I work remotely from Kansas City most of the time. And I used to work here in St. Louis for a long time. But one of the hardest things about going remote for me was I didn't get to do whiteboarding sessions with people anymore. We get to like stand up with your markers, scribble around, bump elbows, actually interact with people in real time. And so we built this drawing robot that you see on the right. And the setup is basically this. Let me reload it and you can watch it again. There's an application on the left, which is kind of a virtual whiteboard. You can see a bunch of little cursors zooming around. There are 18 or so people from all over the place, St. Louis, Portland, LA, and they're all drawing at the same time on a virtual whiteboard. And then I've got a drawing robot in Kansas City in my office, drawing whatever they draw on the virtual whiteboard. And this was just kind of an experiment for fun to see if we could do it. But I think this is really beautiful. What I love about the whiteboard experience is there's direct, real-time collaboration, and there's no friction between the technology and the creation process. And the technology underlying what's happening here, you may not understand everything that's going on there, and that's okay. But the primary technology fueling all this is WebSockets, and that's what we'll talk about in a little bit. So I kind of jumped the gun. Some of you guys are like, who is this guy? He stands up and tells us to take our phones out and scribble on the screen. My name is Andy Wise. I'm our Vice President of Design and Interactive at Paradowski. If you guys don't know who Paradowski is or what they do, I promise this will not be a long pitch. But we're an ad agency located over in Webster. We've got, when I started, we had about 20 people. In 2015, we were named the fastest growing company in St. Louis. Now we have about 75 people, a little bit more than that. We do a lot of really cool stuff. We're about 40 years old. Started out as a design firm, which has been great for us because we turned into an ad agency. We got to keep all the cool design heritage. And it's really impacted our work in a positive way, namely in the form of design thinking, but also in just the raw aesthetics of the stuff that we produce. I think I can safely say that a lot of it's really beautiful work. Those are some of the people we get to work with. My background is in design. As I said, I always really liked design as a kid, and I like to draw and scribble just like you guys were doing. And I studied design, graphic design at Maryville. Graduated there in 2006, took a job as a designer, worked at a company for about 5 years, and then moved on to Paradowski and took another job as a designer. And this time it was an interactive design job. But the reason I'm telling you all this design stuff is because that's really been my main gig as designer. I'm not a developer. I'm about like maybe 25% developer on a good day, but pretty much 75% designer. Which means, like, probably some of you that are just, maybe none of you are just starting out, some of you that are just starting out, I feel a little bit of imposter syndrome, even though I'm running a team of 14 developers and a team of 25 or so art directors and creative directors. I still feel that very much, and I feel it very much in front of all of you who are specializing in JavaScript. So go easy, take it easy on me. Hopefully you get something out of this. So why are we here? I'm not equipped to answer the existential question on the screen here, but I can answer what we're going to talk about, and the agenda is this. So we already talked about who I am. Hopefully you know a little bit about me now. I want to talk about WebSockets and Socket.io specifically, just totally high level. We'll get into some code. I'll do a little bit of a demo of some basic WebSockets code. Just by show of hands, how many people have used WebSockets before? Quite a few. Has anybody used the Socket.io library? Okay, so quite a few. That's good. So you guys will be familiar. You can take a nap while I'm walking through the code. Hopefully some of the experiments after the code will be interesting to you. So let's get into it. I'll give you just a totally high-level overview of what a WebSocket is. So back when I started in 2010 at Paradowski, which is right there on the timeline, a couple of new technologies came out. So one of them was Node.js, had just come on the scene in 2009, and also WebSockets appeared in Chrome as like standard issue for the first time, which was a really, really big deal. Nobody knew what it was. I think most people didn't even know it existed. But in 2010, when I started, I just happened to be looking for something to help me with a project. I was trying to figure out how to move a little box around on a screen, but using my phone. And the way I was doing it was very stupid. I fired up a PHP based server. I had a MySQL database with X and Y values in the table. And I was doing this like AJAX request back and forth from my phone to the server and updating the X and Y values with little buttons. I was like, okay, it's working. The box is moving, but slow, like painfully, terribly slow. It was not the desired effect. And so I started Googling like everybody else does when it doesn't work, and I found Socket.io. It had just come out. It promised to solve everything that I needed, and it did. And I want to talk about that. NPM came out about the same time now. Everybody's using that nonstop every single day if you're developing anything, but especially JavaScript. So that was kind of my entry into WebSockets was back then. Now we're like 9 years out from there, almost a decade out, so it's a pretty mature technology. So whenever I do any kind of development, which is not very often, but when I do, I have to pretty much look up everything as I go. So I'm either Googling or Stack Overflowing or going to Mozilla's site to look up definitions of stuff. Anybody else have to do that, or am I the only one? Okay, good. So this is the definition on the Mozilla site. Save you the trouble of Googling it. WebSockets are an advanced technology that makes it possible to do blah, blah, blah. The important parts are that it provides an interactive communication session, which is interesting. And it lets you do that without having to pull the server for a reply, which was totally my problem. I kept pulling the server over and over and over every time I wanted to update the X and Y value. So you don't have to do that with WebSockets. So if I'm going too far ahead for some folks, here's how a basic web request works. Basic web browsing happens over HTTP. And it always goes like this. The client, somebody on their laptop or the phone or whatever, sends a request to the server, and they say, hey, I'd like to see this web page, please. And the server says, okay, let me think about it for a second, and they process it, takes some time, and then they send the page. And that happens over and over, that back and forth exchange. Well, with WebSockets, it's a little bit different. And for those of you that know what it is, I'm sorry, but this is how it works. Similar starting point. Somebody says, hey, I want to initiate a connection with you, but I don't want a page. I want to establish a relationship. So a handshake request happens. It's literally called a handshake. And so the client sends a handshake request. The server says, okay, let's be friends. They shake hands. Server and client are now friends. And what that means is I don't have to ask for pages. The server will just send me data whenever it sees fit because we're friends. We trust each other. It's all good. Likewise, the client can send stuff to the server as much as they want. It's a full duplex relationship. Data can flow freely both ways. That kind of makes sense? Sort of. So the short version is WebSockets enable real-time web-based interactions. That is the mind-blowing portion of it for me, and that's what inspired me to go on to play with it a little bit and create some stuff. Just to prove that out a little bit more, so this is a graph of WebSockets processing time versus traditional REST processing time. Not my graph, I stole it from somewhere, the credits at the bottom. But you can see, like, if you were sending, on the far right here, a payload of 1,000 bytes, and you sent that 10,000 times, it would take about 10 seconds for traditional REST process to happen, just in raw processing time. If you do the same payload, same amount of time, 10,000, 1,000 payloads, it would take a fraction of a second. So regardless of if you're sending it one time or 10,000 times, for WebSockets it takes just a small amount of time. With traditional HTTP, way more time, which is exactly, again, what I was experiencing when I'm trying to move my box back and forth. The cool, good, yeah.
By doing with a connection and a handshake, right?
Right. Yeah. Yeah, you only have to do, the overhead is really in the, it's like all the headers that you have to send, all the back and forth there, and then just the waiting for the server to do what it needs to do. With WebSockets, you just have to wait once. One request, one set of headers saying, let's shake hands, and then send whatever you want. It's like magic. So this is the can I use it table for WebSockets. You can use it on everything but Opera Mini. It goes back a couple of versions for most browsers. Pretty safe. But even if you had doubts about it, there's a library for that called socket.io. And this is pretty much how everybody uses WebSockets in JavaScript. It's sort of like, I know jQuery's got kind of a bad name now, but it's sort of like the jQuery for WebSockets, or similar libraries that simplify complicated stuff. So Socket.io's interface, like code-wise, isn't a whole lot different than just standard WebSockets JavaScript, but it provides a bunch of benefits. So Socket.io just sits on top of WebSockets like that, hunched over on top of WebSockets. And this is kind of the networking layer. So you've got WebSockets on top of, or Socket.io on top of WebSockets, on top of the transport layer, the network layer, the link hardware. You guys know all this stuff. That's how the internet works. And then above that's the application layer, and then the browser, which everybody uses to get in. Socket.io sits sadly there, sandwiched in the middle. So some of you would say, like, especially people that have used WebSockets before, you might say, well, I don't need Socket.io. I can just write WebSockets. Like, I don't need jQuery. I can just write JavaScript. Well, you can. You can totally get by with that. But Socket.io provides a bunch of stuff, like fallbacks for browsers that don't have WebSocket support. It falls back to things like long polling. In the old days, it would use stuff like Flash sockets and things like that. Automatically handles reconnection. It has this beautiful messaging scheme that lets you send basically any format of data back and forth between the server and the client. And it transposes that into JSON beautifully. It handles things like rooms and client enumeration and broadcasting. So if you want to send a message to everyone that's connected, it's got a provision for that. A lot of really smart stuff, and it's worth using the library. So shall we do some code? You guys have your laptops or anything? If you don't, it's fine. I have, just to prove how vulnerable I'm being in sharing my 25% developerness, I have a single repo on my GitHub account, and it is the demo for this. There it is. So if you guys want to go download it and follow along, you can. But I'm just going to go from scratch and show you like how to go from 0 to WebSockets. Just totally basic. Sound good? GitHub.com/Andy Wise, and it's the only repo, so you'll be able to find it. Because I'm a code hoarder and I'm shy. Yeah. So this is what the code looks like. You guys probably can't see it in the way back. I'm sorry, but here's what we've got. On the left, we have server code written for Node.js, just a basic Node.js server. On the right, we got client code, just an HTML page. And this is it. I'll walk through more specifically, but you've got the setup here to create an Express-based Node server. You guys are using Node, right? Yeah, people are using Node. You've got the routing to handle pointing to an actual index file, index.html, and then the socket, and then listening to start your server, and then the socket IO stuff is all right here. So you listen for a connection, and then you can emit events to the socket that connected, and then you can listen for events from that socket. That's it. On the client side, you've got just a basic HTML page here. All you have to do is include one script, socket.io/socket.io, basically. You connect like this, and then you can listen for messages, like a hello message, and then you can also send messages. That's it. It's like event listeners, just like if you were listening for a click event or something, you would listen for a socket message, and emitting your own events to send to the server. That's really it. If anybody's scared of it, you shouldn't be, because it's very, very easy. So let's open some code and see if I can build it. I've got my cheat sheet behind here so we can get it going. So the first thing I'm going to do is, let me just do a normal, first of all, can you guys see this at all? No? You can see it? How about way back there? Can you guys see it all? Okay. How about that? Can you read that back there? I'm checking everybody's eyes. Okay. All right, so we'll do just a normal like npm init. And then we'll install 2 libraries. So the first I'm going to install is Express. People are familiar with Express probably. It's a really easy way to set up a node server and routing. And then socket.io. So we'll do npm install save socket.io and Express. It's going to download that stuff, stick it in the node modules over here, and update the package JSON. Maybe. There we go. So then we need to create a couple of things. So the first thing would be an index.js file, just to have your node server, file for your node server. So we'll create that file right here. And then I'm going to go into the package.json, and under scripts, just do a start script that runs node index.js. Save that. And then let's edit our server. So I'm going to copy a bunch of stuff because I don't want to bore you guys with all kinds of things that you already know, most of you. All this code is just pulling in our dependencies, so the Express and socket.io dependencies, and setting up the basis for a socket.io server. You've got app, server, and then IO is your variable that's storing the socket.io instance. You guys are probably with me so far. So the next thing that we'll do is do just a server.listen, and that starts the server. You guys are probably familiar with that, but we don't have any routes yet, so I'm going to put a couple of routes in there. One is going to be for just the main index, so I've got slash here. It'll point to a screen.html file. Hope I'm not going too fast for you guys. And then a remote.html file, because we're going to try to replicate what we were doing earlier, which is you got a screen and then you have a remote that you can interact with. Yeah? This line right here? Well, here's the deal. This is all totally magic to me, but server is basically just attaching, it's creating a basic HTTP server, like using Node's built-in HTTP library, and then it's associating that server with Express. It's saying, hey, Express, will you handle the routes for me, please? Okay. Yeah, there are a lot of ways to set this up, but this is kind of a basic one. You got it. Yep, that's right. So these are kind of separate. So this is Express, and just like the default HTTP library for Node, setting up the basic server with the routing, and then Socket.io comes along and says, hey, can I play too? And it says pass the server variable to that. Good, fair question. So then I'm just setting up routes here, so slash, and then I'm doing /r to point to a remote file. And then we should create those files. So let's do screen.html, and then we'll do remote.html. And I'm just going to do really basic HTML setup here. Give it a title, remote. Give it a heading. Oh, was this remote? Yeah, that's remote. We'll do the same thing in screen, but I'll change those values. So this will be screen in the title. Screen. This is all normal, basic, standard stuff. Okay, so we've got a server that is listening, and this is just no Socket.io magic yet. Sorry, we've got to get the server set up. And then a couple of pages. So we'll do npm start. I'll pull up localhost. There we go, we got a screen. I'm going to separate these browser windows so you can see them a little bit better. So we've got a screen, and we've got localhost /r for remote. Cool. All right, we have something that looks like something. So I'm going to clear that out. So what you guys really want to see is how we do WebSockets. So this is how you do that. We'll go back to, first of all, we want to include the library. I'm going to copy and paste this because it's faster. On each of the client pages. So we'll stick this down at the end of the body. And the neat thing about the way Node, doing Socket.io on Node works is it provides access to this compiled JavaScript file. All you have to do is point to /socket.io /socket.io.js, and it'll create that for you. So I'm going to stick this on both the screen and the remote, and then I'm going to create a script right after that and do var socket equals io, and that will instantiate the connection with the server. That's all. That's all you have to do. Which is pretty cool. On the server side, we've already created the server with this I/O thing here, and we just need to listen now for connections. So the way we do that is with just a really simple function that we're listening for an event called connection. So io.on connection. That's the default. I didn't make up the name connection. That's just how it works with socket.io. So once it receives that event, you pass it also a function with one parameter, which is socket, and then you get to do whatever you want with the socket that just connected. So for example, when a socket connects, first of all, let's just do a console.log socket connected, and we'll run this again just to prove that we've connected. And when I reload the screen page, you can see every time I reload, it's telling me that socket connected down here. Likewise for the remote. Maybe. Oh man. Thanks, Chris. There it goes. You can see it down here. Okay, so we have a connection to socket.io. Now we want to do something with that. So I think the first thing that you pretty much always want to do is send some kind of like welcome message to the client that connected to let them know you're friendly and you're safe. So we'll go to our connection handler in our server file. We've logged out that a socket connected, but let's send them a welcome message. So we'll do socket.emit, and emit is your function to send stuff, whether you're on the client side or the server side. And we'll say, hello. And that's it. It's going to emit a message called hello. So on the remote, let's do the screen first. We want to listen for the hello, so we'll do, let's see, cheating. We instantiated it with socket, so we'll say socket.on, and then we're listening for hello, and then we want it to do something after it hears the hello message. So we'll do a console.log again. Server said hello. Sail hello. All right. Server said hello. And that's on the screen. So let's restart that. We'll go to the screen. It's going to connect. It's going to say socket connected on the server side. It's going to send the welcome message, and then the screen that connected says server said hello. If I reload that, the whole thing happens again. Socket connected, sends the welcome message, server said hello. You guys with me so far? Okay. Let's do the same thing on the remote side. So on the remote side, we'll copy and paste that so that if we reload the remote page, we get the same server said hello message. All right, so what we really want to do, I guess, is have the remote talk to the screen, right? So we need a way somehow for the server to know, like, distinguish a screen from a remote. So let's create a function called register screen that lets the screen say, hey server, I'm a screen. You should know that. So we go to the screen on the client side, and we'll say when it connects, after it connects and we get the hello message, we're going to send a message to the server to say, register me as a screen. So we'll do socket.emit, register screen. And then on the server side, we're going to listen for that. So with it inside this connection callback function, we're going to do, let's see, io.on, sorry, socket.on, register screen. Pass that a function that says we have a screen. So I'm going to create a variable up here called screen to store it in memory. So var screen, we call it screen ID actually. And whenever it receives a message, you can get properties of the socket that sent the message. So I can do screen equals socket.id. to store, screen ID equals socket.id. So whenever the server receives a register screen message from a screen, it will store the ID of that socket as the screen variable. I'll save that. Nothing special is going to happen really. But let me log something out so that we can see it. New screen. Screen ID. Got that saved, got that saved. Let's restart the server. So there we go. We get server said hello. Great, I'm a screen. Please register screen. And then the server says, oh, new screen with the ID of XFIC blah, 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 blah. But worth noting is that every time a socket, like a client, connects to the socket.io server, it gets assigned automatically a unique ID. So that unique ID you see there happens every time a new client connects. So if I keep reloading the page, every time it creates a brand new ID for that client. So if I open 5 or 6 different screens, they would all have their own unique address, unique ID. Okay, so we've got a unique, we have a way of identifying the screen. Now we want to be able to send a message from the remote to the screen, which is really where the magic happens, okay? So let's go to the remote file, and we'll do within the hello function, because that lets us know we've connected to socket.io. We will send a message to the server that we want the server to then send to the screen. So we'll do socket.emit, send to screen. I'm making up all the names of these things. Call them whatever you want. And then we're going to say hello screen. We have to listen to that, listen for that on the server, so we'll copy this one. Send to screen. Is that what I called it? Yeah, send to screen. And then when that happens, we want to forward that onto the screen. So we will do io.to, and then we'll include the screen ID .emit. And then we'll say message from remote. And then we'll just forward the data that comes in from the remote, which we can put as a parameter in this function right here. So when we get a send to screen message from a remote, we take the data that the remote was sending, and we send it to the socket with the ID that we stored earlier. And the message this time is called message from remote, and then we just pass that same data that we got. And then on the screen, let's listen for that. So we called this function message from remote, or this message from remote. So we'll do another listener over here. Socket.on message from remote. And when that happens, we want to capture the data that the message or the remote is trying to send. And I don't know, let's just log that out, I guess. Console.log data. All right, let's try that out. Restart the server. We've got our screen, we've got our remote. All right, so if I load the screen, it registers that as a screen with the appropriate ID. When I load a remote, it automatically says, I want to say hello to the screen. Hello, screen. And sure enough, over here, the screen receives the message. Yeah, that's a good question. So if we had multiple screens, let's just do that, and we can prove it out. So we've got one screen over here, one screen over here. About to have one screen over here. So the way we've got it set up right now is the most recent screen to connect to the server is going to be stored as that screen. But that's a totally fair question. The way there are a lot of ways you could handle that, but one way would be instead of screen ID, you might turn that into screen IDs, and then create an object and then just store it as keys for that object whenever you get a new ID. Another question back there?
Yeah, is there, like, what's the benefit you get from storing this? Like, couldn't you just say init this event or whatever and just all else listen for it?
Yes.
You even have to ID them?
Yeah, you don't have to ID them. I'm going through this because a lot of the examples I'll show you follow that same pattern where you've got screen and remote. But yeah, Socket.io makes it really easy to broadcast to everybody that's connected. So if you had 10,000 screens out there and you wanted the server to broadcast to everybody, you could just do, I think it's socket.broadcast.emit, and it would send your message to everybody, regardless of their ID. It would just send it to everybody.
Which means it's going back to the node.
Right, that's right.
There's also a concept of rooms in Socket.io, so you can add connections to a particular room and then message the room altogether.
Yep.
Which is another way to do it.
Yeah.
You could also within rooms also do separate groupings. I can't remember the term for that, but you could definitely get pretty do some general grouping and still get them weird.
So. Oh, that's a really good question. A ton is the answer. I don't know exactly. I'd have to look it up, but I know it's a ton. It's kind of dependent on the hardware of your node server, basically. But suffice to say that it can handle a ton. I've got a really all the demos that I'll show you today are running on a node server that's just a free Heroku server, very low specs, and it can handle tons and tons of connections fine. Yep.
You just mentioned broadcast. What's the difference between just doing
Broadcast will send to all the clients except the sender, and emit will send just directly to whoever you're targeting. So when we do that io.2.emit, it's targeting the socket specifically with that ID. Yep. And then on the client side, we don't do two, we just do emit because it's sending it to the server to do with it what it wants.
Yeah, I think I was confused. I was thinking IO would do the emit, but I assume socket does the
Yep. So let me finish this up and then we'll plow through a bunch of examples. I just want to round this off. A remote is totally useless unless it has a button, so let's stick a button on it. And then we'll do something with the button. So button, I said button. And let's change, because I think on my repo this is what we did. Let's change the color of the background of the screen with that button on the remote. So on click equals change color. So down here we're going to create that change color function. And we want to do a socket emit in there, so socket.emit, change color. And we're going to change the color to red. So let's go to the server and handle that. So when we get, I'm just going to copy this one again to be quick. When we get change color with data, which is probably going to be red, we will do io.2.screenID, emit, change color. You can call it whatever you want, but I'm just going to call it the same thing. And send the data, which is probably going to be red. And then on the screen side, we will do socket.on, change color, capture the data that was just sent, and do something with it. So we'll do document.body.style.background color equals data. And let's see if that worked. Restart the server. remote now has a very fancy button. Our screen is white, but not for long. I'm going to hit color. Oh no, nothing happened. Is that what I missed? I think so. Let's try that again. Hey, it turned red. It just took its sweet time. I said red. Okay, it made it red. That's pretty weird. Internet. I blame the internet. That's cool, but I want to do random color instead. So I'm going to copy my random color code because I can't remember it. And when we do from the remote, we don't want to say red. We want to change it to a random color that I'm going to store as C. And so far, we've just been using strings that we've been sending back and forth, but you could send full-on objects if you want, which is the beauty of socket.io. So I'm going to create an object here with a property of color, and I'm going to pass. What's that? Yes, you can. Yeah, you're right. So I'm going to emit just this object right here that contains the property of color with the random color value that we created up here. And I shouldn't have to restart the server, so I'm just going to reload the remote, reload the screen. What? Oh, yeah, you're right. That's not going to set a color. So we want data dot color, right? Good, I know everybody's listening. Let's try that again. All right, now we get random colors. That's it. That's the whole demo. So it's pretty easy. I hope that if anybody was intimidated by WebSockets or Socket.io, this helps. For me, it was really helpful to see something like this, or just an easy way to get started, honestly, is just to go to socket.io. Their tutorials are pretty decent. Chris asked me earlier when I was going through this at our office, like, should someone just start out with WebSockets, like pure WebSockets, and then Socket.io? And I don't think so. I think Socket.io is a really easy, quick entry point in here. If you want to get into the nuts and bolts of it, go backwards into WebSockets. I think so. There we go. Yeah, there it goes. So we would see that over here too, I guess. Oh, shit. WS, so we'll reload there. You can see some action happening there. If I change the color, no, I guess you don't see it. Oh, there it is, okay. So if I say color, right here, that right there. Oh, okay, cool. God, you guys are so smart. Okay, so every time it sends it, you can see the actual payload coming in. That's sweet. I love that. All right, you can take over. Yeah. I think you can use it on other stuff. You can use WebSockets, but Socket.io is, yeah. I'm totally ill-equipped to answer a lot of questions, but I'm happy to chat after about anything that you guys want to talk about. I do want to get through these experiments, if that's okay with you guys. I've got 15 or so experiments that I'll try to fly through, and you guys are welcome to play with them on your own later on. So that's how you get into WebSockets. That's sort of the foundation of everything that I'm about to show you. So you can kind of keep that in your mind when you're looking at these. That's sort of the basic pattern that's always happening. I fell in love with WebSockets, like I said, about 9 years ago. And the reason I fell in love with it is because of the potential, like the real-time potential of interacting, like way back to that drawing robot example. I think it's cool when people can use technology without a whole lot of friction getting into it. Not a lot of waiting, not a lot of back and forth, just like you're in and you're interacting. And I think that even though WebSockets and Socket.io have been around for a long time, we're still figuring out how to use it. Like relative to the age of the internet and HTTP, still pretty young. And I don't know that we've reached the full potential with it. But I think there are really cool applications in the area of user interfaces. So when I was exploring this, I liked to use familiar patterns to try to mimic. So using the screen and remote model, I wanted to see how many different ways I could iterate on that. So starting with a really basic one, just taking traditional UI, but making it remote. So things like your trackpad on your laptop. Everybody's familiar with that. It's a pretty standard interface device. But wouldn't it be cool if your trackpad was able to separate from your computer, or anybody was able to interact in a trackpad-y way that's really familiar, but using a remote that everybody's got, their phone. So here's what that would look like. So same way we were connecting earlier, taking a picture of the QR code, basically opening that short URL, and I get this gray screen over here that once it connects, it gives me this little dot, so you can see I'm just swiping down my trackpad and it's moving my dot. Pretty cool, right? Even if I wasn't plugged in here, if I was back in Kansas City and doing this, you would still get the real-time, like instant gratification of swiping on your trackpad and getting your dot to move. I don't know about you, but that makes me pretty excited. So what's going on here? Same thing that we were talking about earlier. So I've got a Node.js server running on Heroku set up, cloud-based server. And then when the screen connects to that server, so in this case, I open a URL to be the screen, just like we were doing earlier. Does the handshake thing, says, okay, let's be friends. Let's do WebSockets together. It assigns a unique ID to that screen, like you see right there in yellow. And then the screen turns that into a URL, creates a QR code for it based on that unique ID. That lets any remote that wants to walk up and connect to it have an easy way to associate itself with it. So when the remote comes up, it does the same thing. Connects to the server, goes to that URL, whether typing it in or going through the QR code, doesn't matter. Handshake with the server and says, hey, let's be friends, let's do WebSockets together. And then the magic happens. So when I'm interacting with my screen, my remote, it feels like I'm interacting with my screen because of all the relaying happening on the server, even though there are really two things happening, just like the code example we went through. And just like the example we did at the very beginning, the beauty here is you can have an infinite number of remotes interacting with the same screen. So if you're at an event somewhere and you have like this, you have a big screen up, all of you could interact with the same screen just with your devices that you have on you. It's pretty sweet. Another way to extend this would be in the form of scrolling. So same idea here. I've got a page of dummy content. I've got my trackpad loaded up remotely, and if I swipe, it scrolls the page, which is cool. No interruption, like it's just like my normal trackpad on my computer. Happens instantaneously. Yeah, you totally could. Yeah, or even like a bookmarklet that you run when you're on a page, and it lets you scroll remotely. So trackpads are really cool, but they're not as cool as an NES gamepad. I thought it would be cool to try to do a gamepad metaphor, so let's do that. So now when I connect, I get my little asteroids ship down here, and if I rotate, let's get this so you guys can see it. This is my controller down here. So as I move, I tap and move, I've got this virtual gamepad that lets my asteroid ship move around, go off screen and come up from the bottom just like asteroids. Or if I tap, I can shoot while I'm scooting around in my asteroid ship. So you can imagine, like, I've got one remote connected. If everybody in the room had their own asteroids remote, we could be shooting each other all night long. It'd be so fun. Maybe that's just me. The really powerful thing about these devices is that there's a bunch of sensors, okay? So you can use it as a trackpad, you can rotate it and tap on it and make it a remote, but it's also got gyroscopes and compasses and accelerometers and all that other cool stuff. And fortunately, JavaScript lets you interface with that stuff, some of it, the accelerometer and the gyroscope. So you can get stuff like orientation and acceleration data and interpret it in really cool ways. So basically what I'm saying is everybody walking around with a phone in their pocket has a Wiimote in their pocket if we use it in that way. So it might look something like this. So you've got another QR code that I'm scanning, I'm connecting. And what's happening now is just like the example, if any of you guys pulled it up, you get a ton of numbers flashing on your screen. But this time I'm sending all those flashing numbers as socket.emit messages to my screen, from my remote to my screen. So if I'm holding my remote like this, my alpha, beta, and gamma levels are about 0 everywhere, but if I rotate up, my beta goes up to about 90 degrees, go back to 0. If I rotate this thing to the left, get to about 90 in the alpha, rotate this way, we're about 270 in the alpha. So it's recognizing the orientation of my device remotely in real time on another device, which I think is so cool. Numbers aren't that cool though, so let's do something with the numbers. Let me get rid of some of these. Scan this one. Once you've got that sort of orientation data, you can do really, really awesome stuff. So now as I rotate my device, all of those are being translated and applied to a 3D model. So in this case, we've got Mario dancing around for us. You can see there is no, even like over the projector, there's no lag there. Like, that's crazy. And I think what's especially cool is it's sending really, that's not a small amount of data that it's sending. It's a whole object with alpha, beta, gamma, X, Y, and Z acceleration data all at once in one object in one socket emit, like every, I don't know, I've got it like 60 times a second or something. Yes? No library, just raw JavaScript. You can listen for, it's like on motion event or something. I can't remember what it's called. Maybe somebody else does. Okay.
It's modern. It's HTML5 exposes certain aspects of the sensors inside of Chrome, and I believe inside of Safari. So it's built straight into the browser to allow access to those sensors.
So every device for your accelerometer, you're just
Sending
sending a delta.
the whole payload, yeah. Doesn't have to. It wouldn't have to do that. Yep. Yeah, even if there's no change, which is totally wasteful and unnecessary, but it kind of proves out like how much you can get away with. I don't think so. I think I may have set up on the client side, I may have done a bounce to like throttle how much data is being sent, but even without doing that, it can keep up. It's crazy, right? Like, that's nuts. You guys did this thing earlier. Let's see if it'll come up. know why that's saying test. I'll skip that. You guys already did the virtual cursor. So you guys were drawing with your virtual cursor and your pointer. And the way I set that up is I kind of guessed at what your thresholds for angles would be and constrained you to a left and a right and a top and a bottom. But sometimes you want something more precise, right? So like if you have a gun in your hand, an NES zapper in your hand, you might want to shoot a duck with it. So let's see what that looks like. So in this case, it's the same idea, but instead of guessing at the values, I'm going to calibrate it first. So I'm going to point as though I'm aiming a gun at that green dot and then the yellow dot. And then I get a really precise laser focused pointer so I can shoot that duck. What's that? That's a great question. This is using the phaser.io library, which is like an HTML5 gaming library. Go look that up if you want to do any kind of game stuff. Phaser, F-P-H-A-S-E-R. Handles sounds really nicely, handles animated sprites really nicely. You can see it's kind of like a bitmappy scaled up. It handles that kind of stuff nicely too. You guys use Phaser? Anybody else use Phaser? Oh my gosh, go play with Phaser. It's so fun. So you can shoot ducks with Socket.io. So gestures is the next thing I want to talk about. So you got this data, and I'm going to pull up an example of what that data looks like. We've got these cool sensors in our cool devices in our pocket. And we've got this data, which we see in numbers at the top there, like we were looking at earlier. And then we've got the numbers appearing on our screen. And now what I'm doing is just showing that data for, I think this is just the X acceleration of my device. So if I move to the left and right a lot, you can see the graph goes nuts. It goes up and down. This is just my movement over time. What's cool about the data, earlier we were just translating sort of three-dimensional space to a two-dimensional plane. So we're taking like our alpha value and turning it into an X value, turning our beta value into a Y value. That's a really direct conversion. That's pretty straightforward. But if you look at your sensors over time, like your sensor data over time like this, you can derive some insights about what somebody's doing with their device a little bit more. So for example, if I've got my device like this, swipe to the left really fast, you can see it spikes up and down. If I swipe to the right really fast, you get a similar spike. What's notable about those is when I swipe to the left, it spikes up and then down. When I swipe to the right, it spikes down and then up. So even just by looking at those spikes and the values over time, you can identify without seeing me, you know that I was going to the right and then to the left. Rain's about to start, just saying. So once you know that stuff, you can do some neat stuff. You've got kind of the full potential of the Wiimote in everybody's pockets. Because when you're playing games on the Wii, you want to bowl, you want to hit stuff with a baseball bat, you want to golf, you want to play tennis. You don't want to just move a cursor around. Nobody does that. So here's what you can do with that sensor data. This is a really, really dumb example, but this is a virtual skee ball game. So we've got a ramp over there that's of no consequence whatsoever. And I'm clicking right now and it's sending some balls, but I'm holding my device, I'm kind of moving it a little bit, nothing's happening. But if I sort of make a motion as though I'm throwing a skee ball on this virtual skee ball thing, it tosses a ball every time I make that gesture. And the reason I'm able to do that is because I can recognize, based on the spikes, like the peaks and the valleys in the graph over time, oh, hey, this guy's trying to throw a ball. Let's throw a ball for him. So that's that. Using 3.js to render the 3D stuff here. I'm using, I think, ammo.js to handle the physics. That's how that works. That's cool, right? Dynamic interfaces. So the next evolution of the Wii, for those of you following the Nintendo lineage here, was we sort of skipped over SNES and N64 and GameCube. They don't matter that much, except SNES was great. Then you've got the Wii U that came out. And what was brilliant about this is they put a screen on the device which would give you a controller that gave contextual inputs to whatever you were doing. Like whatever game you're playing, your controller has stuff that goes along with that. And I think that's really smart. And we can apply the same principle to our little Wiimotes that we have in our pockets because we also have a screen that can update. And with Socket.io, you can do that. Not only can the remote send data to the server, but remember, that's a full duplex thing. So the server can send data to the remote. So can I have volunteers to help with this? I know Chris wants to volunteer. Anybody else? I need like one more volunteer. You're going to volunteer? Great. So you guys are going to play a trivia game with me. And it's really hard. So you can scan that QR code or type in that value or that URL, and you'll get a screen. Tell me if you don't get this, and then you don't get to volunteer anymore. But this is you get a screen like that. Okay, choose your character. I'm going to choose the alien. And then, you guys ready? We'll hit play together. Okay, so you get a screen with a question. What disease did the following... Jesus. This is so dark. It was not IBS, it was diabetes. We all failed at that. But what's cool about what's happening here, aside from the really dark, hard trivia, is depending on the context of the game, like we're getting a question with inputs to answer the question, it's telling me very blatantly that I got the wrong answer. And now it's telling us on the screen that we all got the wrong answer. That's a long trivia question. I did not write these. This is from like a random trivia question database, and they suck. Yeah, wait, who is the monster?
I did not get the rest of those.
Over the course of the complete works of William Shakespeare the Brand. Exact. Nice work, Chris. Anyway, you get the idea. There's a lot of power in that, so you can... Hey, it's George. I'm the only one with no... No, I got points. Are you the one with no points, Chris? That's embarrassing. True or false? You got a 50-50 shot at least. Did you get that one?
I got that one right.
Oh, good. Okay, we can move on with the presentation then. So I think there's a lot of potential in that. I think that's cool. It's not exactly Wii U controller caliber, but it's like set up shop at any bar and let people with their phones play trivia on a screen. You cannot have that idea. I'm already working on it. So another application is robots. So I say robots, but what I really mean is any kind of sort of physical computing. You've got things like Raspberry Pis, which are, you spend $5 at Micro Center and you can walk out with a device that can run Node, can run via WebSockets client, and can power motors and lift things. That's crazy. Please go buy a Raspberry Pi Zero W sometime if you haven't already, because it'll change your life. So at our office, we built this thing called, we call it Telepresence Rover, and it's basically just a chassis with a couple of wheels. It's got a Raspberry Pi mounted to it. It's not a Pi anymore, but it's basically a Raspberry Pi. And it's got a 360-degree camera, one of those Ricoh Theta cameras. You push the button and it takes a full 360. What's great about that is you can stream that 360-degree camera through the Pi that you're connected to and broadcast it, which is what we're doing over WebRTC. So in real time, somebody can connect to this, go to our site when we have it hooked up later on, and you can drive this thing around our office in real time, just with your keyboard, going left, right, backwards and forwards. You can see people being terrified of it here. An early prototype looks like this. We've got the Pi Zero standing up in a case with some rubber bands around the camera, keeping it going. That's not the 360 model, but it worked. And what's great about this is not only the camera and people being able to creep around our office remotely, but WebSockets. Again, WebSockets. So the Pi in this place, the Raspberry Pi, is running a library called Socket.io client, just socket.io/client. And it can connect just like any web client would, just like the remotes that we were showing on the screens. And it connects to a server, and then our remote, just like we were doing earlier, our phone is the remote, is sending messages to the server, which is relaying those messages to, in this case, not a screen, but a little robot that you can drive around. The thing drives like a tank. It's got 2 wheels, so you control the motors for each independently. And you can see that we have this little interface. So if you swipe up and down, it'll let the thing spin. If you move one of the motors, it'll kind of rotate around itself. Once it passes a certain threshold, it will, in real time, send commands to those motors and pilot your vehicle. It's nuts. And really, really fun. Drawing robot that we were talking about earlier, this is hooked up in my office in Kansas City. So an annoying thing about this drawing robot is that you have to kind of set up a precise start position before you draw anything with it. And that can be hard if you're like sitting at your laptop and the robot's over here and you're like trying to get it to move, sending it commands. So I made this little calibration app, which my son, 5-year-old son Henry, is holding right there. And when he taps the little northwest button on there, it tells the robot to move up and to the left, just a few motor turns. He keeps tapping it, moves a little bit more. He taps it again, a little bit more. And all it's doing, you can't see it off screen, but down here, there's a Raspberry Pi Zero hooked up to those motors, and it's doing exactly what we were just talking about. Exactly what we did with the code demo, which is the remote sends a message to the server sends a message to the Raspberry Pi says rotate the motors so that thing can move up. Real time, really intuitive, so freaking easy that my 5-year-old son can pick it up and calibrate the drawing robot. What's that? No, there aren't. Those are just, I can talk about this all day. Those are just dumb stepper motors, just NEMA 17 stepper motors on suction cups. Yes. Yeah, it might seem like I have an obsession with whiteboards. I understand that. Yeah, no, this is just for fun. So in this case, we've got a drawing of Tom York, lead singer of Radiohead, rendered in a single line drawing, like a traveling salesman problem solution drawing. And I saved that file as an SVG file, which turns out to be a relatively large SVG file. And I want to get that over to my robot. I don't have to do a post or anything like that. I just send it over WebSockets. So just like we were doing socket.emit and we're sending hello server, I'm doing socket.emit, draw SVG, here's my SVG as one giant string, my entire SVG. WebSockets sends it over to my robot and it starts doing its thing and drawing Tom York on my wall. Same one, yeah. That's right. Yeah.
How long did that take?
I can't remember, but not long, like 10 minutes. Yeah.
What was the quality?
You can see it. It's pretty good.
Did you make that? I need to hang that up or poster it or what?
Yeah. Come to our office. We have one in our office.
I actually have a line on this design, but I can't actually put out one of them.
Do you have that?
I don't have it.
Oh yeah, those are sweet. Yeah, the same idea, but you like stick a router with plywood just leaning up against the wall, and it'll cut out whatever shape you want. Crazy. This one we built from scratch, but same basic principle applies. So another thing we're working on right now, and you guys are all invited to go use this. If you go to eggyo.lk, as in egg yolk, we did not invent this, but there are robots that you can build with 3D printed parts that will draw on eggs. Totally useless except for Easter time. So we built what doesn't exist and hasn't been done before is we built just a basic web app that lets any dummy off the street choose some icons by searching down here in a little text field, like type in the word bunny and you get a bunch of bunny icons. You can use a text tool, you can use a cloud drawing tool, you can use freehand drawing tool. You draw on a canvas and then it renders on this virtual egg. When you're satisfied with it, you hit looks good, and it sends all of that to our server back at our office. We get a listing of everybody's drawings with their mailing address, email address. If you want to get an egg in the mail, provide your email address and your mailing address, and our robots will draw it, and that all happens with WebSockets. So it looks like this. When we get a drawing, we can do, got this little thing that will move a pen around just like the other drawing robot, but this time it rotates around an egg. Yours will not animate like that, but we do. Chris does. Mhm. The plastic eggs.
Oh, okay.
Yeah. Very. We're not sending you a raw egg in the mail. We're not that advanced yet. All right, this is my last demo, and I need volunteers again for this. Chris, will you be a volunteer? Hey, you want to be a volunteer? You actually have to like come up here for this one. I need like maybe 2 or 3 other volunteers. Anybody? Okay, good. Ryan. Anybody in the back want to come up? Anybody? No? Okay, this is good. We got four of us. So I think another opportunity for WebSockets application, which is pretty cool, is like VR, virtual reality right now is for some people is a multiplayer, like multi-user experience, but mostly it's people putting on their goggles and playing by themselves, like doing stuff by themselves. But I think with things like Google Cardboard, it makes it easy for people to get into virtual reality if they want to. And since it's web-based, we can use WebSockets if we want. So let's, all of us are going to enter in a URL and we're going to play a game, okay? Go to boxyay.com/b/jstl. Here's what that looks like. boxyay.com/b/jstl. Please don't you guys go to that because you'll mess up our game, but you're totally welcome to play this later. All right, let me know when you guys are ready. You guys ready? Everybody hit the ready button. Here we go. You have to move around and try to find boxes as fast as you can. Got one? Oh. The first person to find 3 boxes wins, and I lost. Who
I
won?
didn't even see one box.
Okay, let's play again. Ready?
2D boxes, 3D boxes.
3D boxes.
Here we go. Ready? Go, guys, go.
I still don't see any boxes.
Yeah. There's one.
They're cubes, not boxes, by the way.
Well, who won?
I
Chris?
won. Finally.
Okay, that's it.
Win the game.
Thank you, guys. You can go sit down. Thank you. That's it, guys. That's all I have. Thank you for indulging me. I'm happy to talk with you after. I'm terrible at fielding questions because I don't know much about this stuff. I just play with it. But thanks for having me and thanks for listening.